Alright, hi guys, this is 5.4. This is graphs of sine and cosine functions. Now, you did this in Math 3. We did graph sine and cosine, so we're not going to get too in-depth into this. And also, since for this semester our classes are online, please realize that you're not going to have to graph by hand sine and cosine. So it's more about recognizing what do these graphs look like, what are the features of these graphs, if they are transformed, what does each number in those transformations represent. We are going to graph some by hand so that you get used to what do the transformations look like, but we're not going to graph everyone by hand. So let's first look at our parent function, which is sine of x. We get these features of our graph from our unit circle. So at 0, at pi over 2, at pi, and at 3 pi over 2, we're looking at what is our sine value. So I usually go ahead, when I do this back in Math 3, I kind of sketch out my unit circle. So 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So at 0, which is over on the far right, my sine value is 0. At pi over 2, my sine value is 1. At pi, my sine value is 0. At 3 pi over 2, it's negative 1, etc. Okay, and so we talked about, this is between 0 and 2 pi, we talked about the period last notes, so that's how often the graph repeats itself. You might be tempted to say it's every pi because you see 0 and pi, it goes back to 0. However, we have to look at, well, at pi over 2 and 3 pi over 2, they're not the same value. So we have to look at when is it going to get back to 1, and it's not going to get back to 1 until we're back over here at 5 pi over 2. So it's actually going to repeat itself every 2 pi. Alright, the domain of this graph is negative infinity to positive infinity. It's going to go forever to the left and forever to the right. And then the range, and that's actually featured on number 2, is negative 1 to 1 inclusive. And we get that from our unit circle. It goes all the way down to negative 1 and all the way up to positive 1. We also talk about that it's odd. You can see that from it being symmetric about the origin. And we also get that from what we talked about in the last notes, that if we plug in negative x, we get negative sine of x. Okay? Alright, so let's start graphing. Let's graph this ourselves first. Actually, let's start, since they already graphed this, let's just start with the transformation. So we're going to go ahead and break this down. This has two transformations. We have negative sine of x, and we have plus 2. So first of all, this plus 2 is going to move my graph up 2, and this negative is going to reflect over the x-axis. So we know the period is 2 pi, so here's how I always say to do it, is that's going to be the fourth line is 2 pi, okay? So then obviously you're going to have to work backwards, so that means this is 3 pi over 2, this is pi, and this is pi over 2. That should be pretty familiar because that's your unit circle. So that means going backwards, I just have the negative version of that. So negative 3 pi over 2, and negative 2 pi. Alright, so I'm going to go ahead and scale this 1. Actually, I'm going to have to do it each by ones because I'm going to move this up 2. So 1, 2, 3, negative 1, negative 2, and negative 3. Alright, so first I'm just going to start with my parent function. I'm going to do this in different colors so you can see the transformations. So sine of x. So sine of x is going to start at 0, 0. At pi over 2, it's going to be 1. At pi, it's 0. At 3 pi over 2, negative 1. And at 2 pi, it is 0. Then I'm going to go down. And again, I'm just graphing my parent function from the previous page using my unit circle. Okay, so that's the original. Then I'm going to go from left to right, so I'm going to reflect over the x-axis. So the ones that are on the x-axis will stay the same. The other ones will reflect. So I end up with something, oops, not that looks like that. All right, and last step is to move all of these guys up 2. So if it's at 0, it's going to end up at 2, -1, 1. And you always want to indicate, if you do this in colors, that's probably the best way, but you always want to indicate which one is your final. And that's it. Okay, let's go on to the next one. All right, so the next one, we have a 3 in front, and this is a vertical stretch by 3. This is also called what we're going to call the amplitude. And that's just the height of your wave. Then, if it's minus, that means I move right pi over 4. Okay? So, what I'm going to do first is this still has a period of 2 pi. So I'm going to go ahead and 2 pi, pi, 3 pi over 2, pi over 2. Alright, so the vertical stretch by 3, I'm actually going to do that together as my first step rather than just graphing sine, just to kind of save a little bit. So all that means is at 0, 0, instead of going up to 1, I'm going to go up to 3. And then down to -3. So that takes care of the vertical stretch by 3, and then I have to move right pi over 4. Now, you notice that's not on your graph, but 1/4 is half of 1/2. So I'm basically going to move it right halfway in between each of my tick marks. So it's going to end up something like this. And indicating which one is my final answer. And that's it. All right, so that's your sine function. Next, we're going to move on to cosine. All right, so I think if I'm looking at this packet right here, this one page might have been flipped, at least in my packet. I'm not sure if it was flipped in your packet, but make sure you're at the page that looks like cosine before you get to the graphs of cosine ourselves. I don't know if that was my bad or the copy people's bad, but probably mine. So make sure you're at the page that looks like this. So it should look like them graphing cosine first. So cosine is going to start, because cosine is our x values, should start at 1. Because remember, cosine is your x values. Cosine has a lot of the same features as sine. It's going to look very similar. It's going to look like a wave. but a few key differences. So one thing is cosine is an even function. You can see that because it's symmetric about the y-axis. Okay, it still has a domain from negative infinity to positive infinity, and it's still from -1 to 1 inclusive. Okay, all right, so now let's get to those graphs. Now, they already graphed the parent function, so we're just going to go straight into graphing with some transformations, because we'll get to graph the parent function with that. So we're going to go straight into graphing 3 cosine of x. Now 3, remember the 3 in front is just a vertical stretch by 3. Or we call that the amplitude of 3. My period here is still 2 pi. It's going to repeat itself every 2 pi. Remember, that's the same for sine and cosine. So I'm always going to put my period on the 4th line. That's just kind of standard notation. So then pi, 3 pi over 2, and pi over 2. And it's just because kind of that's your unit circle. When we change our period in a few minutes, then that line will change. All right, so this one's not going to be too bad. And we can do this all in one step. So remember, cosine is going to start at 1, but this time it's not going to start at 1 because I'm vertically stretched by 3. It's going to start at 3 and go all the way down to -3. One thing, if you do choose to put arrows on the end, it's kind of like some people put arrows, some people don't. Make sure you turn your arrows over because that function is going down after 3. It goes from -3 to +3. All right, so let's do one more. So this one has a reflection over the x-axis, a vertical stretch by 2, and again that's the amplitude, and it goes down 1. So my period is still 2 pi. All right, so here I'm going to go ahead and do the reflection first. I'm going to do that all in one step. So instead of starting at 1, I'm going to go ahead and start at -1. So again, it's just a reflection over the x-axis. And once you get started, you'll kind of start to see that pattern forming of that wave. Again, just moving from left to right. All right, so next we know that there's a vertical stretch by 2. So instead of going from -1 to +1, we're going to go from -2 to +2. Whoa, don't know what happened there. There we go. All right. And lastly, we're going to take everything and move it down 1. So this guy's going to go down to -3. And keep going. So you got a lot more going on this one. And we're going to indicate on that one. Since we have a lot going on, which one is our final? Okay. All right, so next page. So now I'm going to talk about amplitude and period. We already talked about amplitude. It's the number in front, so it's the vertical stretch of your graph. But we're going to talk about if we change the period. Okay, so on this one, we're given a cosine function, -4 cosine of 3x. So my amplitude, remember, is just that vertical stretch. So I'm just going to write out all the transformations. So reflect over the x-axis, an amplitude of 4, okay, because that 4 in front. Now the period, you can see your formula, it's 2 pi over the number on the inside. So I'm going to write that down here. So period equals 2 pi over 3, and that 3 comes from that number on the inside of my function. So we're going to have to do a little bit of work with fractions here. Oops, that's not what I wanted. So we're going to graph this one and probably one more. We'll probably actually just graph this one and then we'll do the algebra on the next one, because remember, our graphing by hand isn't the focus, but we do want to be able to recognize it. All right, so on this one, so 2 pi over 3, our period is going to go on the last line right here. Now, I have to be able to divide that by 4. So this is 2/3, okay? So I have to kind of think about, well, what could break down if I divide that by 4? 2/3 divided by 4, or multiplied by 1/4. So that gives me, and I can just kind of ignore the pi for right now, 2/12 or 1/6. So pi over 6, 1/6, 2/6, 3/6, and 4/6, which is 2/3. And I'm going to do the same thing going this way. Okay. All right. So -4 cosine of 3x. Once you label your axes that way, nothing has changed, okay? It's just the scaling of your axes. So reflect over the x-axis, amplitude of 4. So instead of starting up, and I'm just going to go ahead and do this now all in one step, instead of starting up for cosine, I'm going to start down. And I can go ahead and just do it. I know I'm going to be at 4 and at -4. Oops, that's 3. Okay, again, reflecting. So instead of starting up, I'm going to start down at the bottom. And amplitude means instead of going from 1 to -1, I'm starting at 4 and -4. And that would be your final. All right, so this one I'm not going to draw the graph for, but I do want us to find the amplitude and period. So the amplitude is just the number in front, so the amplitude would be 2. And the period, I take 2 pi over -pi over 2. All right, so I got to keep change flip here. So 2 pi times 2 over -pi. I can cancel out the pi's, and I get 2 times 2, which is 4, over -1, so a -4 for my period. All right, this last one tells me to write the sine function and write the cosine function. So it is really helpful that it tells you it's cosine and it tells you it's sine. So the two things I really need are amplitude and period. So amplitude is the height of your wave. So to go from here to here, I notice the height is 3. Period is how often it takes for the graph to repeat itself. So I notice to get back to the top of my wave, the period is 1. Okay. So what I'm going to do is then I'm going to write a cosine function. So y equals 3 cosine. Now I also notice it starts up at 3 rather than down, so that means it's going to be positive. All right, so 2 pi over x equals 1, because I know 1 is my period. So I have to solve to figure out what's going to be on the inside. So 2 pi equals 1x, x equals 2 pi. Probably should have used a different variable than x there, but it's okay. So therefore 2 pi is going to go on the inside. All right. Last one is the sine function. So a couple things to notice is the height of your wave for your amplitude, and that's 1, 2. And also notice you're scaling it is by 1, so that's good. So the amplitude is 2. Now, one thing to notice is that sine normally goes up on the right, but this one's going down, so it is going to have to be negative. And then how often does it take for the graph to repeat itself? Now, this is scaled by ones, so in order for it to repeat itself to get back to the top, it's going to take 1, 2, 3, 4. So the period equals 4. All right, so y equals negative 2 sine x. All right, so we just have to find the period. 2 pi, I'm going to use the little w that they use, equals 4. 2 pi equals 4w. W equals 2 pi over 4, or pi over 2. And that would be your final. Okay? So that concludes kind of graphing sine and cosine, finding amplitude, period, etc.